descriptive statistics. Defining the optimal price is one of the business problems. Similarly, there can be many business problems like how do we maximize the revenue, or how do we increase the, of course, maximize the revenue through sales only. And in order to maximize the sales, there are many ways. One is the optimal, how do we decide the optimal price, or which products are more interest to the users, and what are the features that customers are looking for. So there are many dimensions that we have to consider in to maximize the sales. For any business problem, whether it is maximizing the sales or for deciding the or understanding the customer intentions. What I mean by intentions, customer intentions are what exactly he is looking for in my e-commerce site. So for any business problem, we have to start collecting the data. So how do we collect this data? So do we collect this data from Monday to Friday, or during the weekends, or for continuous periods of months? So what is the time frame that we are actually looking for collecting this data? That is very, very important. Perhaps I wanted to look at this data as per the quarter level. In the first quarter, what are my sales? In the second quarter, what are my sales? So whether my sales have been improving or not. So these are the some kinds of data points that I'm actually looking for. So now, if we take these 4 products, and before I start analyzing or taking any decision, I would like to take the help of descriptive statistics to understand the data. Let us take a very simple example here. In this example, I am showing product 1 sales, product 2 sales, 3 and 4 in different months starting from January 2015 to May 2015. So looking at this data, what can we really infer? Okay, before we infer anything from this data, let us get the summary of the data. Okay, so what is the summary of the data? If you look at this one with a naked eye, I can say that all right, there are very good number of sales in February. Here product 2 also there is good number of sales in February, whereas in product 3 there is in March there is a good number of sales, and in product 4 in February. So not only like that, okay, so we have to use some kind of measure that we have to use before we summarize the data. Let us take an Excel example. Okay, so these are the 4 products that I'm talking about and their sales. So when you want to summarize this data in Excel, okay, because everybody is having a good exposure to Excel, so that's why I'm taking the example of Excel here. So if I want to see, if I want to get the summary of this data, so I will prepare another table for each of these product, okay, within this time period that is having these are the measures. What are those? Which is, what is the minimum number of sales happen? 220. This one. What is the maximum number of sales? 542. What is the sum of the total sales? Okay, which is nothing but in this given time period of this data that I collected for these products, out of these products, for the product 1, the total sales are happened is 1753. Okay, and also mean. What is mean? Mean is nothing but it is the average of the sales those are happening. Average is the sum of all the sales from January to May and divided by the number of months. Okay, since I am looking at the data at the months, then it is the sum of these product sales by the number of months. Okay, that is nothing but 1753 by total 5, which is 350.6. So the average number of sales happened is 350.6. And what is the median? Median you calculate, okay, you just keep all these values in the increasing order. What I mean by increasing order, which is starting from 220, 224, 311, 456 and 542. This is what the increasing order. Okay, just for your information, I'll write down here 220, 224, 311, 456 and 542. So when you calculate the median, okay, you have to just start moving from left 1 point as well as right 1 point. Okay, again left 1 point and right 1 point. So which is nothing but the center of the all these arranged ordered numbers. So which is nothing but this is the median. Okay, so here what we have to keep in mind is that when I'm going to discuss about the distributions, okay, whenever you want to see the profile, what I mean by profile is that um, any variable, okay, I'm going to explain about variables as well very soon. Any variable that is going to, I mean to say here the variable is sales of the product one. Okay, for example, any variable, let us say this is the variable. In that variable that will have mean and median. Okay, so that, okay, first I want to describe about the profile. Profile is nothing but any variable that will have certain characteristics, okay, that can be represented in the form of min, max, sum, mean, median and standard deviation. This is called profile. If somebody comes and asks me, hey, what is the profile of the sales of product 1, then I would say, hey, the profile is, it has a minimum number of sales of 220 and maximum number of sales of 542. The total number of sales of that product from January to May 1753, and the average sales happen to be 350.6, and the median is around coming out to be 311. So whenever I say the profile means, immediately it should trigger in our mind that this will have all these values. All right, so if somebody comes to you and asks you, hey, can you perform some profiling on this data, which means that they are expecting all these different values to understand what is happening in that particular variable. Now, I just mentioned that please keep in mind this mean and median are very important characteristics of any profile, which means that the distribution I'm going to talk about of any variable can be easily characterized by these two values, and also these two values help us in identifying the whether the distribution is the required distribution or are there any skewness in the distribution. So anyways, so keep in mind that these are very two important parameters of any profile. So now here I'm talking about the similar way for the product 2 and product 3, product 4. So this is the complete summary of the data that I'm presenting it here. All right. So now, is this summary sufficient for you? Is this summary sufficient for you? No, this is not sufficient. There are some more other characteristics that I'm going to introduce that would be helpful for us to characterize the data. Let us take an example. Okay, let us say this is an example which is actually talking about how do you compare the two distributions of, okay, two distribution. Before I use the word distribution, I just use very simple English. There are software, there are salaries of two companies in San Francisco and New York of different designations like junior software engineer, senior software engineer, project lead, manager and senior manager. So these are the salaries of two different companies. Okay, one is in San Francisco, another is in New York. Now, if somebody comes to you and asks you, hey, can you just profile this data? When you profile this data, okay, means the salaries of these people, what do we want? Okay, the first one is, what is the minimum salary of the company that is located in San Francisco, which is 5,000, and what is the maximum salary, which is 55,000. And it is good that it is already in the ordered one right here. The salaries, as the designation is increasing, it's quite obvious that salary would also increase. So now here I wanted to know what is the mean of the salary. So here I have just populated my summary. When I actually summarize this data, the minimum of both the companies is coming out to be the same, maximum is same, mean is same, and median is same. But if you and I observe this data of this very small data with the naked eye, we can see that the senior software engineer of, of a person of this company in San Francisco is higher than in New York for the same designation. Here, in the project lead, New York organization is paying more than San Francisco. But when you summarize the data is coming out to be same. I mean to say that summary is looking same, right? The min, max, mean, median are also looking same. But this is not the actual case here. There is some variation among this data that is called the variability, or we can say that dispersion. So I'm going to describe about dispersion here. Dispersion of Dispersion describes the variability of the data. So we need few more measures to to actually evaluate the characteristics of the profile. The first one is the range. Range is maximum minus minimum. Oh, here also the max and min, the range is coming out to be same because the max and min are same for both the companies, right? Then let us go to the other one, which is mean absolute deviation. Mean absolute deviation, which is nothing but, suppose you are having 5,000, this junior software engineer who is earning 5,000, how far is he from the mean value? The mean value is 30,000 here, right? The mean value is 30,000. And how much this person is varying from the mean, and which is the absolute value, that is the mean absolute deviation. Mean how much this particular junior software engineer from San Francisco is deviated from the mean, which is an absolute value. All right, so which is nothing but 30,000, so 5,000 minus 30,000. Okay, similarly software engineer of this San Francisco. So I calculated for all of them, and when I sum all these values, the mean absolute deviation is coming out to be 15,000 here, whereas for New York it is coming out to be 25,000. So which means, what exactly this is actually giving me the information? This information gives me that the company in San Francisco, the people who are earning money are very close to the mean than the people who are in New York, right? So these people are, let us say these people are 5,005, three of them, or three designations are complete, are 25,000 distance away from the mean, right? And these people are again 25,000 points, I mean the salary points away from the mean, right? So the mean absolute deviation is nothing but the sum of all the mean absolute deviations, okay, which represents this one. So here we found this particular MAD, mean absolute deviation, is helping us to find out the variability across the two profiles. Am I right or not? Neither the mean nor max or any other mean, median, range was not actually giving us the variability in the data, but mean absolute deviation is giving us. Okay, now we are going to the variance. Variance here, okay, which is the same difference but square of that, and we calculate the variance as the sum of all these values, which is the variance. Similarly for the New York. And then once we calculate the variance, we can calculate the standard deviation. How? Standard deviation is equal to square root of variance, right? So which is here in this case the standard deviation is 17,078 and 25,000 for the New York based organization. So this value is giving some information. What is that information it is giving? Which gives how much these salaries are varying from the mean. Okay, how much it is deviated from the mean. Okay, so this is second measure. I mean to say third measure, range, which is coming out to be same. Mean absolute deviation, yes, it is giving good value, good information, as well as variance. Now let us see what is coefficient of variation. What do you mean by coefficient of variation? The variation, that is, which is nothing but the variance that we calculated, okay, and then standard deviation we calculated, okay, and the mean. The coefficient of variation is nothing but the standard deviation by mean. How much it is deviating divided by the mean value. So the coefficient of variation, so it is coming out to be 57%, whereas here 83%. So if you look at these three measures like mean absolute deviation, variance and coefficient of variation, these are all actually capturing almost all the same kind of information but in a different units. What I mean to say is that mean absolute deviation gives us the information that most of the salaries are not away from the mean. And here the coefficient of variation, which is also giving the information that there is not much variation in the data when compared to the people who are in New York. All right. So there are cases where whenever you are summarizing the data, you are getting the same kind of values, but data is not capturing that. Okay, I mean to say the data properties are different. So now these are the some of the measures that will help us in identifying the different properties of the data. Now I will explain these skewness with the graphical plots as well. In fact, I would explain all these concepts with the plots as well, but this is an example trying to show you that whenever you get the data, what are the different characteristics that I should consider to describe the data. So coefficient of skewness, yes, coefficient of skewness is actually, this is the, I'm straightforward giving you the formula here, which is the mean minus median by standard deviation. Whenever mean is equal to median, the coefficient of skewness will become 0. And whenever the coefficient of skewness is 0, then you should be very happy that the distribution is not skewed. Skewness is a property of the data that is centered towards, that is centered means that is actually not for, that is the mean and median are not equal, where it is moving towards either left or right side, which means the distribution is skewed. Skewed means it is actually not following the very good distribution.